Hi there! Now in the last two videos, we have looked at two mathematical problems which are also very famous interview questions related to recursion. Now in this lecture, we will look at a few more interview questions which are asked frequently in interviews. But here I want to mention that there are a lot of questions related to recursion which I have not included here, because these questions cover other topics that we have not covered in this course yet. As we progress, those kinds of questions will be presented. Now let's continue to the first question. As you see, the first question is how to find the sum of digits of a positive integer number using recursion. We know that we have three-step process for this. So as always, first we need to start from first step. So what's our first step? The first step is to find recursive case, the flow. So the question is how to find the recursive case for the sum of digits of an integer number. First, let's see how can we find digits of any given number mathematically. Now imagine that we have a number of 10. Now we need to somehow divide this number into digits, which are 1 and 0. So how can we do that? So if we look at this number carefully, and we see that if we divide this number with 10, we can get these digits separated. So let's divide this number with 10. The result is 1 and the remainder is 0. That's exactly what we want. We have separated these digits, then we can sum up these digits together, which will be 1. So by dividing 10, we can get the digits of any given number. So let's see another example. Let's imagine that we have a number of 54. So if we implement the same process here, 54 divided by 10, we see that the result is 5 and the remainder is 4, which are the digits of 54. As you see, this logic works very well. And if we check this logic for any given two-digit number, we see that it works without any problem. Now you might be interested in how this will work for 3-digit and 4-digit numbers. Now let's look at another example, which is 112. So as we did before, we divide this with 10, and we have a result of 11 and the remainder 2. As we see that the last digit of 112 is 2, so the remainder is fine for us, but the first two digits are still together, so we need to separate these digits as well. So how can we do that? So we will call our process recursively, which means that we will divide 11 one more time with 10. So if we divide 11 with 10, we will get a result of 1 and the remainder is 1. As you see that the digits of 112 is 1, 1, 2. So as we did here. So if we sum up these numbers, we can get the sum of digits of 112. So we see that for 3 digits number, we need to implement the process of dividing with 10 one more time. And this means that we can write our recursive case like this. So here we are dividing n with 10 and taking the remainder and summing up with the next value of our function, which will be called recursively based on n divided by 10. So if we check this equation for 112, we see that 112 divided by 10, we will have 2 over here because this is the remainder, and we will call our function recursively with 11. When we divide 112 to 10, then we are getting 11. And here, again, it comes here, 11 divided by 10, we have 1 here as a remainder, and then our function will be called with 1. In the next case, we will have as a remainder 0, so we will have a base case to stop it. We will look at it. So based on this recursive case, let's create our initial Python function. So let's switch to Visual Studio Code. Here I will create new function, which is sum of digits. The function will take n as a parameter. Then it will return integer n modulo 10 plus, we will call this function recursively with this parameter, integer n divided by 10. So this is the initial version of our code. So let's run our function with any given parameter. I will run it for sum of digits for 4. Let's run our file. So we see that again we have an error of maximum recursion depth exceeded while calling a Python object. And this means that our function calls itself infinitely. So we need to prevent this case. So we know that for writing a recursive method, we have 3 steps. In the first step, we have found our recursive case, and we have second step, which says that we need base condition for any recursive function to stop infinite loop. So let's think what can be a base condition over here. Now here, I want you to pause the video and think what can be a base case for this equation. Alright, let's see what's the base condition for this equation. So if you look at our equation over here, we see that our n becomes less and less in each call. And this is the nature of recursive methods, that we divide problems to the similar subproblem, which means that in most cases, the base condition for a recursive method will be 1 or 0. So if we check this equation for 0, we see that the sum of digits of 0 is 0. So we can use this case as a base condition. So let's switch to Visual Studio Code here and write our condition over there. So here in the beginning of code, we will write if n equals 0, then we return 0. Otherwise, we will call our function recursively. Now if I run our function for 4, let me just save this. We see that we don't have any output value here because we have not printed out. Let me print it out. So the sum of digits of 4 is 4. So if you, let's make it for 2-digit number. Let's run it for 12. We get 3. Let's try it for 3-digit number, 112, and run it. And we see that 1 plus 1 and plus 2 is 4. And we see that everything works very well. So we don't have any problem with our function. This function calculates the sum of digits of any given number. But we have not finished yet. As you know, we have third step left. So what is the third step here? It is an unintentional case. So once here, I want you to pause the video and think if you can come up with what condition do we need to include here as step 3. Alright, let's see what we missed for our method. The tip here is we always need to recheck our definition or the question. If we read our question carefully, we see that it says have to find the sum of digits of a positive integer number. So the first case is the number must be integer and it has to be positive number. Now we have read our question very carefully and let's check our function for these cases. Okay, let's switch to Visual Studio Code again. Now let's run our function for negative integer number. I'll put minus 11. So I'll save and run it for this number. I see that it returns 18, which is a strange number. So, and our question says that we need to find it for positive integer numbers. So how do we do that? So we are going to do it as we did before. We will use assert keyword. So assert n greater than equal to 0 and integer n must be equal to n. Otherwise, we will say that the number has to be a positive integer only. So I save it. So let's rerun it for this case one more time. We see that it raised 0. It says that the number has to be positive integer only. Just correct this. Positive integer only. So if I run this, for example, for different number, let's try one 4-digit number, 1, 2, 3, 4, and run it. We see that it says 10. So 1 plus 2 plus 3 plus 4 is 10. So let's try it for another number. I'll put 5-digit number and run it. It gives 5. So everything is all right. So we have implemented all 3 steps here. As a first step, we have found our recursive case. This is over here. Then in the second step, we have identified our base condition, which is n equals to 0. Then in the third step, we have identified an unintentional cases, which are n has to be positive integer number. So this is all for this lecture. Hopefully you understand how we create recursive function for calculating sum of digits of any given integer number. So let's continue to the next question. Question number 2. How to calculate power of a number using recursion. So here again, we will implement our 3 steps. As always, we need to think about our first step. What's our first step? The first step is to find the recursive case. So the question asks how to calculate power of numbers. So from that we know that nth power of any given number can be expressed like this. For example, 2 to the power of 4 means that we multiply 2 4 times with itself. So here we need to find recursive case. And from that, we know that when you multiply 2 variables or 2 numbers that have the same base, you can simply add exponents. For example, if we multiply x to the power of a with x to the power of b, we can easily write this x to the power of a plus b. And similarly, if we multiply x to the power of 3 with x to the power of 4, we can write it like this: x to the power of 3 plus 4, which is 7. So based on these conditions, we can write our recursive case. So we can write this expression here like this: x to the power of n equals to x to multiplied with x to the power of n minus 1. This means that there's 1 over here. So if I sum up this 1 with n minus 1, I will have xn. So now we have our recursive case. We can continue to code our initial version of our function. So let's switch to Visual Studio Code and write our function there. So here I will create our function power, which will take 2 parameters. First parameter will be base, and second parameter will be exponent. Then we will write that expression that we have written in the slide. So it will return base multiplied with power base with exponent minus 1. So this is our initial version of our function. So if we try to run this function for any given number, let me just run it for 2 to the power of 4. Let me clear this part from here. We see that maximum recursion depth exceeded. Once again, our function calls itself infinitely, which means that we need to prevent this case. So for this, we know that we have a second step. In the second step, we are defining our base condition to prevent infinite loop of our function. So here, I want you again pause the video to come up with your own answer. The reason why I'm doing this, to encourage you to engage in interview questions. And by engaging, you will understand it very well, compared to just listening. So pause the video, think about it. Alright, let's see how can we prevent this infinite loop over here. So here again, we will go to our second step to find the base condition. So if we think about powers of any given number, we can easily remember that any given number to the power of 0 is 1, and any given number to the power of 1 is itself. So we can use this condition as our base condition. When n reaches the 0 or 1, we will print out these cases over here. So let's switch to Visual Studio Code and write our code there. So here, in the beginning, I will write our base condition. So the first case is if exponent equals 0, then return 1. Then we have another if case here. If exponent equals 1, we will return base. So if I save this function now, call our function over here one more time, you see that it's not returning anything because I haven't printed out. Okay, let me just put print statement over here. So if I call our function, we see that it's 16. So to the 2 to the power of 4 is 16. So in this case, our function works properly. So everything is fine, but we have a third step left. And you know that without step 3, we cannot finish our writing of recursion code because there might be some unintentional cases. So one more time, I want you to pause the video and think about unintentional case of this function. Alright, let's see what we missed for our method. Okay, let's go to the step 3. Here it says that unintentional cases. To check these cases, let's run our method for different scenarios. So here I have different scenarios. The first scenario, I will take base as a negative number and exponent will be positive integer number. And in the second case, I will check base non-integer number and exponent will be integer number. And in the third case, base will be normal number, integer number, and exponent will be non-integer number. And in the fourth case, base will be integer number and exponent will be negative integer number. So let's run these scenarios for our function, see what's happening. Okay, our first case is negative number and exponent is fine. So I'll run this case for our function. You see that everything is fine, so it returns 1. So minus 1 to the power of 4 is 1, which means that our first case is working fine, so we don't need to worry about this. Then I'm continuing to the next case. In the next case, I'll put base as a non-integer number, which will be 2.2, 3.2, and save it. And let me clear here and rerun this. And we see that this case also works fine. So we don't have any problem with these cases. Let's continue to the third case. In the third case, the base will be integer number, the exponent will be negative number. Let's run this. We see that in this case, our function again calls itself infinitely. So we need to prevent this case. So let's check our fourth case. In the fourth case, it will be a non-integer number as exponent. So here I'll put 1.1. Save it, and let's clear this again and run it. You see that here again we have the same problem, which means that our function calls itself infinitely. All right, let's write our case over here. Here, once again, we will use assert method, and we will take it only for exponent. So exponent must be greater or equal to 0, and it has to be an integer number. Otherwise, we will raise an error saying that the exponent cannot be. Okay, let me write this. Exponent must be positive integer only. Save. So if I run our function for this case one more time, we see that it's not running infinitely anymore. It's just saying that the exponent must be positive integer only. So if I run it for a negative number as well, I should receive the same error. So here again, I receive the same error, which means that we prevent the case of running itself infinitely. All right, guys. With this lecture, I've explained another interview question related to recursion. This one was a little bit easier. So let's continue to question 3. Question number 3. So here we need to find greatest common divisor of two numbers using recursion. As always, we will start with first step. So we need to find recursive case for greatest common divisor. So first of all, let's define what is the greatest common divisor of two numbers. In mathematics, the greatest common divisor, also known as greatest common denominator, greatest common factor, or highest common factor of two or more non-zero integers, is the largest positive integer that divides the numbers without remainder. For example, greatest common divisor of 8 and 12 is 4. So how do you find this? One of the methods of finding GCD to find the prime factorization of two numbers. So for 8, we can write it 2 multiplied with 2 and multiply with 2. And for the 12, we can write 2 multiplied with 2 and multiply with 3. So here, what are the common values? We see that we have 2 for 8 and 2 for 12, which are common values. So if you multiply 2 with 2, we will get 4. So the greatest common divisor for these two numbers is 4. So another method of calculating greater common divisor is Euclidean algorithm. This algorithm uses the divisor algorithm in combination with the observation that GCD of two numbers also divides their difference. So according to Euclidean algorithm, when we find GCD of 48 and 18, the first step that we are going to do, we will divide 48 with 18, and the result is 2, and the remainder is 12. Then in the next step, we will divide 18 with 12, the remainder. So here the result is 1, and we have remainder 6. Then in the third step, we will divide 12 with 6. So the remainder is 0. So when we have remainder 0, this means that in this case 6 is a greater common divisor of these two numbers. As you see, we can see recursion here. Every time we are taking second number and calling this function with as a first number, then taking remainder as a second number. So by taking account these steps over here, we can write our GCD function like this. As you see, in each case, b, which is 18, comes to the first parameter, and remainder of these two number goes to in place of b. So this equation can be our recursive case. So based on this equation, we can write initial format of our recursive function to calculate a greatest common divisor. So let's switch to Visual Studio Code and write our function over there. So here I will create new function which will be GCD, greatest common divisor, and this function will take two number, let's say a and b, and then it will return calling itself recursively GCD, but here instead of a we will have b, and instead of b we will have a mod b. Okay, let's save our function and run it for any given number. So let's take the example that we used there, GCD with 48 and 18. Let's run our function. We see that the function raises error saying that integer division or modulo by 0. So how can we prevent this? So here I want you to pause the video and come up with your own answer. In this way you will understand it very well. So pause the video and think about it. Alright, let's see how can we prevent this zero division. So here again, we know that we have step 2, in which we need to define base condition. So if we go back to our Euclidean algorithm, we see over here that we have a condition here which says that if b is 0, then GCD of these two number is a. So we can take this condition as a base condition and write in our code. So let's go back to our code. So here in the beginning of code, we will write if b equals 0, then it will return a. This is according to Euclidean algorithm. Else, we will run our function recursively. Let's save this and let's rerun our function for this, but before running it, let me print out it here and save it. Let's rerun it. Here we see that the answer is 6. So we calculated it before that. The GCD of 48 and 18 is 6. So which means that our function works properly. So we know that we haven't finished yet because we have third step that left. So what is the third step? It is an unintentional case. So once here, I want you to pause the video and think if you can come up with what condition we need to include in step 3. Alright, let's see what we missed for our method. Once again, I'll go back to our slide. Step 3 is unintentional cases. The first case is we need to take into account that numbers are integer. As mentioned in the definition of GCD, here we see that it is the largest positive integer. So it should be the positive numbers. Then the second case is we need to convert any negative numbers to positive number, because the GCD of negative numbers equals to the GCD of positive numbers of same number. So we need to add these two cases in our function. So let's go back to our Visual Studio Code and write these cases over there. So here in the beginning of code, first I will write our first case, which is both numbers should be integer. So I will use assert keyword here as well. Assert A equals A and B equals B. So here, otherwise I'll put that the numbers must be integer only. Okay, let's put our other cases. If A less than 0, then we will change it to positive number by multiplying it with -1. So A assigned to -1 multiplied with A. Then in the next case, if B less than 0, then again B assigned -1 multiplied B. So let's save this and, for example, run our function for -18. If I save this and run this, let me clear here. So this looks great now. So if I run it, I see that again we have result 6, which means that everything is clear. So, but let's check one more condition here. Let me put here 1.8 and save and run it. You see that we have the assert case comes over here. Our function raised an error saying that the numbers must be integer only. So here everything works well now. So step 3 has been successfully implemented. So we have implemented all 3 steps over here again. In the first step, we have identified our recursive case, which is this part over here, which is calling the function recursively. And then in the second step, we have identified our base condition. Our base condition is that when B, the second number, is 0, then the GCD of these two numbers is A. So then in the third step, we have identified our unintentional cases. So our unintentional cases are the numbers must be integer number and they have to be positive number. If we insert any negative number there, we are converting it to positive number. So, alright guys, with this lecture I have explained another interview question related to recursion, which is calculating the greatest divisor of two numbers. Now let's continue to the question 4. Question number 4. How to convert a number from decimal to binary using recursion. In this question, we need to convert decimal number to binary number using recursive function. As always, we need to think about our first step, which is to find the recursive case. First of all, let's see how can we convert a decimal number to binary number mathematically. To do so, we have a standard conversion steps like this. So first step is we are dividing the number by 2. Then we are getting the integer quotient for the next iteration, and then get the remainder for the binary digit. Then repeat these steps until quotient is equal to 0. Let's see how this is working on an example. Let's say we want to convert 13 to binary number. We see that here, as a first step, we divided 13 with 2. Our quotient is 6 and the remainder 1. So one more time, we are dividing quotient by 2. And 6 divided by 2, quotient is 3 and the remainder 0. And one more time, we need to divide quotient by 2, which is 3. So we are dividing it by 2, and here we are getting 1 and the remainder is 1. So we are repeating these steps until we reach 0 as a quotient. So here we divide 1 with 2 and the quotient is 0 and remainder is 1. So the binary number will be 1101. As you see that we are starting from back and coming forward. So here 1, 1, 0 and 1. We are combining these numbers and we are getting the binary number. So let's look at one more example. Here we want to convert 10 to binary. As you see, we divide 10 by 2, quotient 5, remainder 0. Then quotient is divided by 2. Again, we get another quotient, which is 2, and the remainder 1. So one more time, we divide it by 2, quotient 1, and remainder 0. And in the last step, we are dividing 1 by 2 and quotient 0 and remainder 1. So our binary number will be 1010. So that's how we convert a decimal to binary. The point is, we need to find the recursive case, our method. Without recursive case, it's not possible to develop a recursion function for a given problem. So how can we do this? This is just a little bit tricky, but if you practice more, these things become more clear. So if you look at our example here, in which we are converting 10 to a binary, we see that we need to find somehow solution to get this number over here. So if we combine last two digits from here, we have 10 here, 1, 0, which is kind of 10. How can we get this number from here? By combining these last digits. So if we multiply the last remainder with 10 and plus this remainder, we will get 10. So in the next step, we will multiply this value and plus remainder, we will get this value over here, which is 101. So if we join these numbers 101, it is 101. So one more time, if we multiply this number with 10 and plus this remainder, we will get 1010, which is the binary number that we are looking here. So if you look at it from top to down, we can easily say that we take the remainder and plus the value that comes from the next iteration and multiply with 10. So our equation will become like this. So here, this part is the remainder that comes here. In this case, will be 0. 0 plus 10 multiply fn divided by 2, which is in this case 5. N is 10, so in this case will be 5. You can easily see that this equation can be written like this. So here we have our recursive case. So we can easily switch to Visual Studio Code and write our initial function. So let's switch there. So here I will create function. Let's see, mul to binary. It will take n as a parameter. Then it will return n mod 2 plus 10 multiply with recursive code, which will be n divided by 2. So our initial function will be like this. So let's run this function for 10. Decimal binary. Let's do it like this. And save. Let me clear. Now if I run this function for 10, we see that Python raised error saying that maximum recursion depth exceeded. This means that our function calls itself infinitely. So we need to prevent this case. So we know that we have second step to prevent such cases, which says that we need base condition for any recursive function to stop infinite loop. So let's think what can be a base condition over here. Now here, I want you to pause the video and think what can be a base condition for this equation. All right, let's see what's a base condition for this equation. So if we look at our calculations, we can easily see that our equation gets stopped when it reaches 0. So which means that if we run our function with parameter of 0, then it will stop. So in this case, we can use n equals to 0 as a base condition. So let's switch to our Python code one more time. So here, in the beginning of code, we will write our base condition. If n equals 0, then we will return 1. Otherwise, we will run our function recursively. Else, then we will return this value. But we need to take into account that this part of code should be in integer to get integer quotient. So if I run our function one more time with the parameter of 10, let me clear here. You see that we got the value, but the value is not correct because here return value should be 0. Let me save it and rerun it. You see that this is the binary number for 10. So if I run this function for 13, the one that we did before, you see that it's correct now. We did a mistake here. We put as a return value 1, but it should be 0. Now we haven't finished yet because we have third step. In the third step, we need to take into account unintentional case. So let's think about what can be an unintentional case for this function. Here, I want you to pause the video and think about this. Okay, let's run our function for different scenarios to find the unintentional case. So till now, we run our function for positive integer numbers. Let's run it for -13 to see that what will be the binary number for this. You see that it's fine. Our function returns correct figure. So what else can we check here? Let me put some non-integer number here, 1.2. So if I run this, you see that it's not returning correct value because binary numbers should be 0 or 1. But here we have 2 here. So we need to prevent this case. So to prevent this case, one more time, I will use assert keyword. Assert integer n must be equal n. Otherwise, we will say that the parameter must be an integer only. Let's save it. Let's rerun this. I'll clear this. You see that we receive error saying that the parameter must be an integer only. So we solved all cases. So in the first case, we have defined our recursive case, which was a little bit tricky. Then in the second step, we identified our base condition, so which is n equals 0. Then in the third case, we have identified unintentional cases. So we prevent these unintentional cases with using assert keyword over here. All right, in this video, we have created a recursive function for converting decimal numbers to binary, and hopefully everything is clear regarding this question. And if you have any questions, do not hesitate to contact me. I will try to explain it in more detail.